This is Anita Wood, and welcome to this topic snippet video. It's a review of a concept that we first learned in elementary school, arithmetic operators. All programming languages offers a multitude of operators for manipulating data. Before we move on, we need to define some important terms that makes this discussion easier. Operators perform operations on data. The data that operators work on are called operands. Notice here there's an assignment operator and an addition operator. And there are operands, and they are called cost and tax. Generally, there are three types of operators: unary, binary, and ternary. These terms reflect the number of operands an operator requires. Unary operators require only a single operand. For example, consider the following expression here. For we know that it represents the value -5. We can also apply, using that one, the same operator to a variable like number. This expression gives the negative of the value stored in the variable number. The minus sign, when it's used this way, is called the negation operator. Because it only requires one operand, it's also a unary operator. Now, binary operators work with two operands. The addition operator is in this category. Ternary operators, as you might have guessed, require three operands. Now, we don't see them in this course, but if you continue learning Java, you're going to have the opportunity to be introduced to a ternary operator. It's called the conditional operator, and it creates a shorthand expression that works like the if-else decision statement. Arithmetic operations are very common in programming. Remember, a computer was initially designed as a calculator. Each of these operators work as you probably expect. Now, this table shows examples for each of the operators that we're going to work with in the course. There is another operator that you may see if you're using a specific language. It is called modulus. Now, I'm only going to mention this here. I'm not even writing it down in my table, but there will be more details if you are in a language that has the modulus available. It's possible to build mathematical expressions with several operators. This statement assigns the sum of 17, x, 21, and y to the variable answer. Some expressions are not that straightforward, however. Consider the next one. What value will be stored in outcome? Look closely at where I highlighted. Okay? The 6 is used as an operand for both the addition operator and the division operator. So the outcome variable could be assigned either 6 or 14, depending on when the division takes place. Now the answer is 14, because the division operator has what's called a higher precedence than the division operator. I hope I said that right, but I'm going back and restating it. Has a higher precedence than the addition operator. Operator precedence is something we first learned in elementary school, but let's clear away some of those cobwebs that may have developed around this concept. Mathematical expressions are evaluated from left to right in general. When two operators share an operand, the operator with the highest precedence works first. So we saw 6 is shared between the addition operator and the division operator. The operator that goes first is the one with the higher precedence. Multiplication and division have higher precedence than addition and subtraction. So the statement here works like this. 6 is divided by 3, yielding a result of 2. 12 is added to 2, yielding a result of 14. The multiplication and division operators have the same precedence. The addition and subtraction operators have the same precedence. The assignment operator has the lowest precedence, which means it is the last operation that will occur. Well, that makes sense because in programming, the assignment of the calculation results is the last thing that occurs. So ultimately here, the value 14 is assigned to the outcome variable. The very last item in our operators is the assignment. Now, if two operators sharing an operand have the same precedence, they work according to something called associativity. A new term alert. Associativity means you work from left to right or right to left, as this table shows. So now we've added a whole nother column. This one came from elementary school. Unary, multiplication, division, addition, subtraction, assignment. Now what this column is going to help us with is when there is a multiplication and a division and they're sharing an operand and we have to figure out which one needs to go first. So let's clear that up with some examples. Here's a simplistic example. A equal B equals C. All the operators have the same precedence. Well, obviously, since they have the same operator. So we can figure out what the variable A finally contains. B or C? Because the associativity direction in the table, assignment operators are a value from right to left. The evaluation process for this statement is that C is assigned to B and the new value of B is assigned to A. I know this is really a silly statement because ultimately A equals C would accomplish the same thing without the middleman B, but I use it only for the demonstration of associativity, not for its usefulness. Here's one that looks a bit more realistic. I'm using the example from the Geek for Geeks website. Multiplication and division have the same precedence, and their associativity is left to right. So working through this, you get 100. What happens here is, remember we said that there was going to be a shared operand, and this 10 is shared with the division, and it's shared with the multiplication. So which one occurs first? Well, when we work in the associativity, we go from this direction, 100 divided by 10, which we drop the result down, and that's 10. And we're still moving from left to right. So we hit the multiplication, 10 times 10 is 100. Notice this statement can be written more explicitly using parentheses. Operator precedence and associativity are two characteristics of operators that demonstrate the evaluation order of sub-expression in the absence of these parentheses. If you want to control and not let the evaluation sequence be left up to the computer, use parentheses. These parentheses are going to also help those reading the code interpret your evaluation intention without much effort. Here's one more worked out example from Geeks for Geeks website. The original statement is shown here up at the top. Looks pretty complicated, but we can see through the numbered steps that it gets worked out. So let's follow along. First, we use precedence. We see that here is step 1, which it already shows us, but the division will happen before this addition. So let's take care of that. 200 divided by 10 gives us 20. Now we're moving along, this subtraction occurs, but what happens here is this 3 is shared with the multiplication and the subtraction. So the multiplication has to happen first. So now you get the number 2. So ultimately, this is condensed down. I added this little line here to help you, that the next evaluation process is going to look at 100 plus 20 minus 3. It's here 100 plus 20 minus 3, but it's a little harder to see, so I added it up here. Now you see that 20, the operand 20, is shared by a plus operator and a minus operator. And now we use associativity and find out we go from left to right with a division, addition and subtraction. And with that, the next step is going to be we add 100 plus 20, we get 120, and then that result of 120 is subtracted by the 3. And that's 30. I didn't type that right. I apologize. And there's your 90. Okay? Parts of the mathematical expression may be grouped with parentheses like we said just a minute ago, and that forces some operations to be performed before others. In the statement shown here, sum A, B, C, and D is divided by 40 without the parentheses. However, D would be divided by 4, and then the results would be added to the sum. Subtle, but it is important if somebody is calculating my paycheck. I'm going to think it's important. So here's some more examples for you to look over. Stop the video and spend some time to understand how these expressions are actually evaluated. And can you come up with the same value that's sitting here? Now this discussion goes further than the textbook. And I do this because I believe that sometimes we take the concepts surrounding arithmetic operators and we are a little too quick to brush over them. But without a real solid understanding, you're going to be troubleshooting operations in the code into the wee hours of the night. So what I hope is that this discussion allows you to identify logic errors that exist in your code with respect to arithmetic operations. And that concludes this topic snippet video of arithmetic operators.